All right, so with today's topic, the first thing that we're going to talk about is scientific notation, which happens to be target 1.1. Now, with scientific notation, a bunch of you guys already know this. This can be used to write numbers that are both very, very large or very, very small, which is something that scientists have to do frequently. Because if we're talking about like the size of an atom, obviously a single atom is very, very, very small. And so, in terms of like meters, it's actually like all the way down to like times 10 to the negative 18th meters is like the size of an atom. Whereas if we're talking about something like the diameter of the Earth, that's something that's incredibly large. And so we have to do this quite a bit. Now, to do this, we actually multiply a number by a power of 10, usually written as times 10 to the x power, x just being a positive number or a negative number. And then from there, we just kind of a side note, we always write scientific notation with the number before the power of 10 as a whole number, meaning it has to fall within the range of 1 and 9.99. So we should never write scientific notation as something like 0.45 times 10 to the, let's just say 13th power. So we should never start it with 0. The other thing is it should never be a number greater than the 9.9999 or greater than 10, meaning it shouldn't be something like 55.3 times 10 to the third power. That is not what we want. So the first number should always be between 1 and 10. All right, so let's look at it. So if we have a really, really small number, remember this would be where we have a negative power of 10. And so for this, when we're looking at it, our 0.00000056 originally has two sig figs. So in scientific notation, it should keep those two sig figs. So it would start off with 5.6 times 10, and then let's look at the power. And so we want to move it between the 5 and the 6. So it should be 1, 2, 3, 4, 5, 6, 7 spots. So it's 10 to the negative 7th. Now, if we're writing a really, really large number, like 976,000,000 or 97,600,000, this originally has three sig figs. And so when we write it in scientific notation, it should still keep those three sig figs. So 9.76 times 10, and then let's count the spots that we need to go. So if that's where we want the decimal, between the 9 and the 7, we have to move it 1, 2, 3, 4, 5, 6, 7 spots. So this would be 10 to the positive 7th. All right, well, now let's look at it the other way. Let's say that we're starting off with the scientific notation and we need to write it in the normal fashion. That means that if we have 3.45 times 10 to the negative 8th, we have three sig figs to start, which means we should keep three sig figs. And so since it's to the negative power, that means it's starting off with some leading zeros. And if it's 8, we need to move it 1, 2, 3, 4, 5, 6, 7, 8 spots. So there's our new decimal. And let's count the zeros. So 1, 2, 3, 4, 5, 6, 7 zeros. So it should be 7 zeros. All right, and then 3, 4, 5. All right, so now let's do it the other way. 5.79 times 10 to the 5th. This has three sig figs, which means our answer should keep three sig figs. And since it's a positive power of 10, remember that means the decimal is moving to the right. So it's a really big number. So 5, 7, 9, and then let's count the zeros. So 1, 2, and then 3, 4, 5. So that should be 3 zeros, or 579,000. All right, so now let's talk about our next topic, which happens to be rounding with sig figs. And that's the idea of rounding to significant figures. Now, a lot of times we have to round to a certain number of significant figures at the end of a calculation. And so the idea is first you need to determine how many sig figs are in the original number, then round that number to the correct number of sig figs. So our question here is, how do you write the following numbers with 2 sig figs? Well, if we start off with 56.7, this originally has 3 sig figs. So if we need to write it with 2 sig figs, that means we need to round based on the first 2 significant figures. So the 5 is going to stay, the 6 counts for the second sig fig, and so now what we need to do is there's kind of our cutoff line, and we ask ourselves, does a 7 round up or does it round down? Hopefully you agree and say that it rounds up. So that would mean that this would be 57 when it's rounded to 2 sig figs. All right, well, let's look at another one. We got 157. Again, this one has 3 significant figures originally. So we do the same thing. We keep the 1, we keep the 5, and then we look. Does 7 round up? Of course it does. So the 7 causes the 5 to round up to a 6, making this 160. And remember, this only has 2 sig figs because there's no decimal point here. So as long as we don't add the decimal point, it's only 2 sig figs. All right, our next one, 1,458. Whoa, this one has 4 sig figs. So we do the same thing. We look at the first 2 digits that are significant, so the 1 and the 4. So there's our cutoff line. And then we ask, does the 5 cause the 4 to round up? Now, whenever this kind of happens, you only look at the first digit afterwards. So in this case, we're looking at the 5, and we're looking to see if the 5 causes it to round up. And in this case, of course it does. So that means that this number becomes 1,500. Now, this does bring up kind of an important point here. Let's say instead of 1,458, let's say it was 1,448, and we needed to round it to sig figs. Now, if we keep the 1 and the 4, and then we look at the next number, so for this, we only look at the 4. We don't care what's after that. So even though this is an 8, in fact, it could be a 9, it could be several 9s. It really doesn't matter. We're only going to look at the very next number. And so that is one important point when it comes to rounding, is you don't want to look at this 9 and say, oh, well, the 9 causes the 4 to round up, which then would cause this to round up. No, it doesn't work like that. You only look at the very next number that's getting cut off. All right. Hopefully there aren't any questions about that. So let's look at another one, 58.24. And so for this is 4 sig figs originally. And so now, as we go through it, we keep the 5 and the 8, and then we look, does the 2 round up? Nope, it doesn't. So this number just sticks at 58. And then finally, our last example here, we got 59.8. And so with 59.8, this is 3 sig figs. And so as we work on rounding to 2, we keep the 5, we keep the 9, the 8 gets left off. And so the 8 is going to cause the 9 to round up. Now in this case, that means our number here is 60. But 60 by itself is just 1 sig fig. So what can we do to make it 2? Because we can't leave it at 59, and we can't round it up to 61 because that's changing it too much. So it has to be 60. So the one thing that we can do to make it 2 significant figures is to add that decimal point, making it 60 point. All right, let's look at a little bit more, or a few more examples here. But this time we're rounding to 3 significant figures. And so our first number, 167.2, this is 4 sig figs. We look at where we round. So the 1, the 6, the 7 stay, and the 2 does not cause the 7 to round up, so it's just 167. All right, then our next one, 1,111. Again, 4 sig figs. We keep the first 3, and then the last, there's our cutoff. We look, the 1 doesn't cause it to round up, which means that it's just 1,110. Now that's an important point. Yes, we're cutting off the last 1, but remember it turns into a 0. So that's a very, very important point, is if you're cutting stuff off when you're rounding, remember it turns into zeros. It doesn't just disappear. There's a big difference between 1,110 versus just 111. So make sure you keep that 0. Otherwise, our next example, we got 1,458. We keep the 1, we keep the 4, we keep the 5, and the 8 causes the 5 to round up. So this is 4 sig figs. So it becomes 1,460. Last example here, we have 1, which is really only one significant figure, and we need to write it with 3. So the way that we turn fewer sig figs into more sig figs is by getting a little, kind of creative with the use of a decimal point and zeros. So if we need to write 1 with 3 significant figures, it becomes 1.00, which now has the 3 significant figures. All right, so now this brings up another kind of big question here. Well, how do we write the number 1,000 with 3 sig figs? Because keep in mind, if it's originally 1,000, this is only 1 sig fig, right? Now, if we add a decimal point to the end, all of a sudden, this is 4 sig figs. So we can't just add a decimal point to the end, but if we add it after the first 3 numbers, we just turned 1,000 into 100. So we can't do that either. So all 3 of these options are bad. And so the way that we can do it is actually through using scientific notation. And so anytime you need to kind of change a number with a lot of zeros and get it so it only has a certain number of sig figs, scientific notation is the way to go. So with that in mind, when we're asked how do we write the number 1,000 with 3 significant figures, just like we did in our last example, we can write 1.00, and now that has 3 significant figures, but in scientific notation, it's going to be times 10 to the positive 3rd power. Now, using scientific notation, basically the idea is anything before the times 10 part is your sig figs. So if you're trying to round to a certain number of sig figs at any point, whatever comes before the times 10, whether it's a positive exponent or a negative exponent, that part is your significant figures.